So to splitting a disease, to construct a decision tree. So to construct a decision tree, the most challenging and interesting part is the for splitting a node. How we will choose over which node we have to split. Just in previous lecture, we have already seen that this splitting technique we have taken by using the information gain. The maximum information gain, we have choose this node as a splitting node. Okay, so construct a decision tree. To construct decision tree, the most challenging part is your most challenging part is your splitting the node. Okay, I think challenge spelling is okay. CHLNG. Okay, so this how we will choose to which node we have to split by simple using the maximum information gain in this previous lecture. We will choose the splitting, how to split a node by simple using the maximum information gain. Okay, so the information gain is to calculate the information gain. How we are using the entropy concept here to calculate the information gain, entropy concept, or you can choose the Gini impurity. Both are the same thing. Gini impurity, but we always prefer Gini impurity because it is computationally efficient. We always prefer Gini impurity because it is computationally efficient. Okay, so the most of the library used Gini impurity because of that reasons. It's here we are using the squares. Okay, but here we are using the logarithm, and logarithm always computationally intensive. Computational, they are taken to compute logarithms. It's taken a large means large amount of time then, and then square computational of the square. Okay, large means to compute a square value and to compute a logarithm value, always logarithm value is takes much time than this. Okay, till now we have shown the discrete random variable or categorical features. Discrete random variable, till now we have shown that the discrete random variable, or we have shown the categorical features. But in this lecture we will learn how to splitting a numerical features. Okay, see, so suppose let's take we have a data set like that. Suppose let's take we have a data set like that. And here we have, suppose let's take a features project, a features and corresponding. Suppose let's take we have a features like 2.2, 2.6. It is a numerical features. If we have taken these features as a numerical feature. Okay, 2 point, let's take for an example 2.6, 3.5, 3.8, 4.6. Suppose let's take 5.9, 6.2, 7.3. Suppose let's take and corresponding output. Suppose let's take we have binary output 1 or 0. Okay, so suppose let's take we have output like that. Okay, we have output like that. So this is a numerical features and corresponding output we have taken here binary output. So here fi, here we have fi is a numerical feature. Its corresponding numerical means what? Its corresponding value will be integer or a real value. This type of features is called the numerical features, or it may be a real value feature. A real value. Okay, now the challenging we have seen if we have three categories. Suppose we have a features like suppose we have a feature suppose we have a features if c like that, it is a categorical features and it's have three category. It's have categorical features and it's have three category. Category 1, category 2, category 3. Then how we divide this our parent data set based on these features by using sample. If we have three category, then we can for these features fc, for these features fc, we have divided our whole data sets by using this category. By using sample this category. But how will do this kind of job for these features? But the question says, but here the question says, how we do this job for this kind of job for this category? Arrow sign will be like that. How we will do this job for numerical features? Okay, now this is the question. This is the big question. This is the main motto of this. Let's see. So first we have to do sorting our first we have to the first job that we have to do first we have to sort these numerical features according to ascending order or descending order as you like. So first job we have to sort. So first sort the numerical features according to ascending or descending order. Okay, descending D S C. Okay, descending order. Okay, as you like. We have to first doing this job. First we have to sort our numerical features according to ascending or descending order. Now, so if we just sorting this thing, so just I am already taken this example that's are already sorted. Okay, that's are already sorted. So if this is not sorted, then first we have to sorted this data, sorted these quantities according to as you like, ascending or descending. So what we'll get in such scenario? So this kind of data we have get after sorting. So now what we'll do? So after that we have to break the features. We have to break these features. Suppose if we break these features, if we break these features, I'm taking here another. If we take these features in two parts, all the data sets, if we take this thing in all the data sets, then we got these two parts value. If we break this data set in two parts, then we can this partition's value, then this partition's value. If we divide the whole data sets on these two parts, then we get these two partitions value. Now in second step we have to do, we have to divide it. We have to divide it our features on corresponding to the age value. Means if I suppose here it is features, here fi features, we have to compute with the fi less than is equals to 2.2, this one, or fi less than is equals to 2.6, this will be one category, or fi less than is equals to what, 3.5, this will be another category. Like that we have to build this thing, or this will be another conditions, what, fi less to 7.3. This kind of conditions we have to make to divide this. So how many, if we have f number of data sets, if in this data sets, if the point of the data sets d is equals to n, then how much possibility we have to divide this category? So then we have such kind of n possibilities here. We have such kind of impossibilities to divide such kind of. Okay. Now in third step we have to do, in third step we have to calculate the information scale for age category, for age criteria. This is one decision, this is one decision, this is one decision. So there have n kind of possibilities of decision. So now we have to calculate the information scale for age category, for age criteria. This is one criteria. If this criteria is hold, then how type of constructed data set we will see. Suppose let's take these conditions hold, then these are our data sets. Then if we divided our whole data sets according to this, if fi less than 2.2, then what will be the value this side only we have 2.2 value, and this side we have, sorry, if we have, suppose let's take 2.2 less than is equal, suppose let's take less than, in this side we have 2.2 to how much, 7.3. Okay, suppose let's take, I will divide our whole data set like this. This is our day, we will divide it our whole data sets. fi is less than is equals to 3. And in this side how many data sets we have, this side we have data set like this, 2.2, 2.6, 3.5, and in this data set, in this side we have how much data sets, in this side we have 3.8 to 7.3. Okay, I think you have understand how this thing. Now in third step we have to do, in third step, now in third step we have to do, we have to find the informations gain. Okay, so after splitting such kind of n possibility, so we can make in such kind splitting, okay, for each category, for each criteria. Okay, now suppose let's take, if I less than is equals to less than tau 1, suppose let's take it's a threshold value, then corresponding this tau 1 we can build this part, this splitting for this threshold value. Such kind of n threshold value we have for each numerical quantity. Suppose let's take its threshold value is tau 2. Then we can divide this as like this, and suppose like that, suppose like that. Suppose we have n. Suppose we have n possibility. Then we can divide it this one like. Now for each splitting, we have easily find the information gain. Suppose let's take its information gain is ig or ig1. Its information gain is ig2. Let's take its information gain is ign. Now for n's possibility, here actually we have n possible splitting criteria. This one is the n possible splitting criteria. Splitting. M possible splitting criteria, this one. And for n possible splitting criteria, we can find n possible information gain value. Okay, now at the final we have to choose the criteria which have maximum of criteria. So we have to choose the maximum criteria, maximum informations among all I is equals to 1 to all informations. Suppose let's take our maximum informations gain is ik. Okay, k for this. So suppose let's take our ik like appear on here. Okay. Suppose let's take this one is the maximum max one. Suppose let's take this one is the max one. Max one. Okay, among all this one the max one. Suppose let's take this one is the maximum one. Then we have to choose this criteria. We have to choose this criteria to splitting this data, for splitting this data. Okay, now we have to choose we have to choose PK criteria for splitting the data. Okay, I think you have understand this thing. So for numerical it is simple. I think through this lecture, for this whole explanations, you can easily understand this. This is the simple. So first we have to, for if we have a numerical features or integer features, means if you have simple and numerical features, means it is integer, it may be integer or it may be real valued. If we have such kind of features, then first we have to sort these features according to ascending or descending order, as you like. Okay. Now after that we have to find the possible criteria to splitting the features. Suppose if we have n number of data points, so then we can find n number of such possibilities to splitting the criteria. Among all the criteria we have to calculate the information gain. Now among all the information gain, we are choosing the maximum information gain value, and according to this information gain value we will choose this criteria for splitting our data. Okay, the same thing, just we have to doing the sorting thing here and nothing else. Okay, now the questions is that, sir, if we have large number of data sets, then there may be a chance for a huge time complexity. If in general we have seen that, in general we have seen that n is very large, then in such scenario our time complexity is increased. In such scenario our time complexity is increased. So here time complexity is increased. So how we will decide? If we calculate it for every criteria the information scale, it will take a huge amount of time. So how to, this is a right process. So just there are some hacks how to choose a criteria for splitting the data. There are some beautiful, most elegant hack. So that we'll see in next lecture. Okay.